right, welcome back to another one of Mr. Martin's math videos. This is a video for British Columbia Math 9. Chapter 6, Section 1, we're looking at solving linear equations this chapter. All right, we're going to start with solving one-step equations, then two-step equations, and going on from there, and increasing in complexity for our algebra skills, okay? So by the end of this lesson, 6.1.1, we're going to spend some time working on our foundation on algebra. We're going to learn to solve model problems with linear equations involving one operation. Okay, and we're also going to use multiple strategies to solve linear equations with rational numbers using one operation. Okay, so we'll use different methods. So in this chapter, we're actually going to start doing some algebra. We've done a little bit in some of the questions from last chapter, but we're really going to build our foundation a little bit stronger here and get in some even more complex algebra questions, okay? So the skills you developed in this chapter are very important because much of the survival in high school mathematics primarily depend on your understanding of algebra. So what is algebra? Let's break it down to some basics of what is an equation. Okay, so for an this is an equal sign. Okay, so you guys know an equal sign, right? When you answer a question, you get an equal sign. These are examples of expressions. So we know that, like terms and expressions, you have 4x or 20. For something to be an equation, we stick them together. You have an expression or multiple expressions connected together. Here's a different color. Connected together with an equal sign. Okay? We call everything on the left of the equal sign the left side of the equation. And everything on the right side of the equal side, the right side of the equation. Okay, so the main difference between an equation and an expression is that an equation has the equal sign in it. Okay, and you can remember that by equation, equal, okay? It basically takes two expressions and make them equal to each other. And by doing so, it allows us to solve for the precise value of the unknown variable in our expressions. Okay? So the primary goal of algebra is to find the unknown value of a variable. So think of a variable as a blank space or a spot where a number should go. Let me just make my cursor a little bit smaller here. So here, another way of writing 4x. So the original equation there, another way of writing 4x is equal to 20 is 4 times blank is equal to 20, right? Because x, we don't know what x is, but it's multiplied to the 4 together to make 20. So if I were to ask you this, 4 times what would give you 20, what would be the answer here? Maybe 4 times 5, right, would equal 20. So here in this situation, we can determine that x is equal to 5, okay? So it should be pretty obvious that the answer is 5, but we somehow need to show this algebraically. This requires a little bit more work than just stating what the answer is. To show our variable is equal to 5, we need to do something called isolating the variable. Okay? To isolate the variable, all we need to do is get it by itself on one side of the equation. The final isolated form, as well as the process involved, will look something like this. Okay? 4x equals 20, and then you're going to do the magical algebraic steps, and then you'll end up with your final answer of x is equal to 5. Okay? Now, some of these questions you'll be able to just look at and solve, right? Just because you know your multiplication tables. However, obviously we're going to be dealing with other rational numbers that will be a little harder to solve just by looking at it. So we actually have to do the algebraic steps here to get our answers. Okay? So notice that the variable is isolated in this step here. The only thing on the left side of the equation after we've done the algebra magic is that x. So whatever is on the right side of the equal sign then is what is equal to what is on the left side of the equal sign, which is just the value of x. So x is equal to whatever's on the right side. In this case, x is equal to 20. All right? And the value is equal to the other side. So we see that. Okay? Algebra versus just knowing. In algebra, we begin with our original equation. From there, we manipulate each side of the equation to obtain the variables in their isolated form. Sometimes the answer, like I said, is obvious from the beginning, such as in the case above. However, just knowing what the answer is based on intuition is not always helpful. Consider the following slightly more advanced algebraic equation. All right, what is the value for k here? Are you able to determine the value of k just by looking at this equation? Probably not, right? So it's not so easy now, is it? However, if you pay close attention, the skills and techniques taught here in grade 9 you should be able to master of algebra come grade 11 and beyond. The above equation is actually from pre-calculus 11, and the answer here is k is equal to 6. Okay, but you wouldn't have guessed that just by looking at this. Very important when we're dealing with algebra. So being a math teacher, I've seen a lot of students solve equations in many different and creative ways. Some of them are quite ingenious, while others are just downright confusing. Based on my observation of other students' work as well as my own personal study, I've discovered that the most important concept to remember when solving algebraic equation is balance. Okay? By this I mean that both sides of the equation must always equal the same value. If there's ever a moment in your equation where both sides are not equal to the same value, you have done something wrong and need to go back to fix it. Consider the following equation and that will hopefully help you remember this. So stuff on this side is equal to the same value as the stuff on this side. And that has to remain true no matter what algebraic steps you take. So really, when you think about it, what else can an equal sign mean? That's what an equal sign means, right? It just means what is on the left side is equal to what's on the right side. It's a symbol that means this is the same as that. Granted, the left side and right side of the equation often look different, but their inherent value are always the same. Okay? So here, for example, this equation, the left side and the right side look different, but their inherent value, because we figured out that x is equal to 5, 4 times 5 is equal to 20, they are actually equal to each other. And that's what that equal sign is assuring us of. So by knowing that the left side and the right side is equal to each other, that then allows us to solve for the variables. That's why you can't solve for variables in expressions, because you don't have an equal sign. So you can't determine the value of the variable. All right? So in order to preserve this balance of the left side of the equation being equal to the right side of the equation, it is important. You can do whatever you want to either side of the equation. The important thing, though, is that whatever you do on one side of your equation, you have to do to the other side of the equation. With this in mind, let's start looking at some fundamentals. So just to emphasize this point here, for example, let's start with a really simple equation. 1 is equal to 1. Okay, this is an equation, and it's obviously true, right? 1 is equal to 1. Okay, now I can add and multiply and divide anything I want here to both sides of this equation. However, whatever I do to one side, I have to do to the other side so that the equation stays true. Okay, so for example, I know that 1 equals 1. Okay, what if I did plus 5 to both sides? Plus 5 plus 5. Okay, then I would get 6 is equal to 6. All right, and that is still true. Okay, and it's still true because I did it to both sides. If I just did plus 5 to one side, would my equation still be true? I would get 1 is equal to 6, and 1 is obviously not equal to 6, so it would be untrue. So that's why you have to do everything to both sides. Okay, even multiplication division, right? If I divide both sides by 2, Oops. If I divided by 3, I wouldn't get something that's equal. But if I divide both sides by 2, I get 3 is equal to 3. And again, my equation is still true. Okay? Even though the numbers on the left and the right side have changed, the fact that the left and the right side are still equal to each other means your equation is still true. Okay? And that's the key. All right. So let's get started here. Solving simple equations in the form of ax is equal to b. All right, so solve the following equations. Check each solution. So for this equation, think about how you would get rid of the negative 6 in front of the x, and how can you make it disappear, while at the same time not changing the value of either side of the equation. All right, so here I get the equation. I'm going to rewrite my equation. Negative 6x is equal to 42. All right. So here, my end goal is to just get x by itself, right? Because if I can get x by itself, I know that the right side of the equation will just be the value of x, and then I've solved for the value of x, which is the point of this. So here, I need to figure out something to do to the left side of this equation, and really to both sides of this equation, that will make that negative 6 actually equal to 1. Okay, because if I can make that equal to 1, 1 times x is equal to x, and then I only have x left. Okay, so here, because it's negative 6 times x, if I do negative 6 divided by negative 6, and again, that's going to equal to 1x, right? That's going to equal to 1x. Let me put that in 1x, right? And you don't have to do this middle step. Okay, I'm just trying to highlight this clearly. Because here, negative 6 times negative 6 in brackets is equal to 1. And 1 times x is equal to just x. So it's essentially that negative 6 disappears when you make it equal to 1 when it's a multiplication. Okay? Obviously, also notice that because it's negative 6 times x, I divide both sides by negative 6. Okay? So oftentimes in algebra, you do the opposite of the sign, and you essentially cancel out the coefficients of the numbers by doing that. So because it's negative 6 divided by negative 6, that is equal to 1. 1 times x is equal to x. So I'm in good shape here. Here on this side, negative 42 is divided by negative 6 here is equal to negative 7, right? We can double check that. So that's going to equal to negative 7. Okay, so here, because it's 1 times x, and 1 times x is just x, I know here that x is equal to negative 7. Okay, and you can double check your answers here. You never have to get any of these wrong, because you can double check your answer, because you can always plug the value of x back into your equation. So if I say negative 6, x is equal to 42, and I substitute the value of x that I've solved for, what I think is the value of x, into my equation, it should give me 42. So negative 6 times negative 7 is equal to positive 42. Okay, so I know that I've done it right because both sides of my equation are correct. Let's do another problem here. All right, here 2x is equal to 3 over 4. Okay, so here we got a fraction that we're going to be dealing with here, but that's all right. Again, here my goal is to make that 2 a 1, because 1 times x is equal to x. So I'm going to divide both sides by 2. 2 divided by 2 is 1, and 1 times x is x. And then whatever I do to one side, I need to do to the other side. Okay, this is going to give me 2. Sorry, this is not going to give me 2. It's going to give me x is equal 1x, but I can just write it as x, is equal to 3 over 4 divided by 2 over 1. Okay, I'm going to turn the 2 into a fraction. this is the same as this, okay? Because I'm dividing a fraction, and we know that to divide a fraction, we need to multiply by the reciprocal. And that's going to give me x is, write the final answer here, x is equal to top times top, 3 times 1 is 3, bottom times bottom, 4 times 2 is 8. And that's my final answer. And I can double check my final answer by plugging it into my equation. 2x is equal to 3 over 4, 2 bracket 3 over 8 is equal to 3 over 4. This is, I can make this over 1, right? And this gives me 6 over, let me make this in red so you're following my work. 6 over 8 is equal to 3 over 4. And 6 over 8 reduces to 3 over 4 is equal to 3 over 4, right? If you divide both the top and the bottom by 2. Okay, so I've done this correctly once again. All right, let's try another example here. Now we can solve this equation using 2 different methods. We said that we look at 2 different methods of solving, or various methods of solving equations. These ones, there's 2 methods for this specific type questions when you have matching fractions like this. We've seen these already before, but this will kind of be a review. One is what we've been doing, the opposite operation. Okay, so if I have m over 3 is equal to negative 2 over 5, how am I going to get that? I need m by itself, so m divided by 3, I need that 3 to equal a 1. So I'm going to multiply both sides. I'm going to multiply it by 3. So m times 3 divided by 3 is just equal to m because the 3's cancel out. Okay? And then whatever I do to one side, I do to the other side. Okay? This is going to give me m is equal to, because the 3's cancel out, or they equal 1, and 1 times m is equal to m. And then 3, of course, that invisible over 1, right, when you're multiplying, gives me negative 6 over 5 as my final answer. Okay, or you can cross multiply. Cross multiply, let's just rewrite this. For cross multiply, if I take the denominator of 1 times the numerator of the other, the product of the 2, that's going to equal to the product of the denominator of the other and the numerator of the other. So if negative 2 times 3, the product of those 2 is equal to 5 times m. So here you get negative 2 times 3 is negative 6 is equal to 5m. And then here, this is similar to a problem we saw earlier. So divided by 5 divided by 5, m is equal to negative 6 over 5. Either way, you get the same answer. Okay? So that's a couple methods you can use. You use cross multiply, but cross multiply really only makes sense when you have matching or kind of fractions on either side of the equal sign. Otherwise, you don't really want to use that method. Okay, you want to be using the opposite operation method. Is the more is the one that you can use in all algebraic situations, where cross multiply is only for specific situations. Okay. Last one, and then you'll have a chance to practice some of these. So for these types of questions here, you want to turn all fractions into improper fractions and go from there. Okay. Now again, when you're dealing with a negative improper fraction, it's important that you're kind of doing the minus instead of plus there with the numerator. So negative 2 times 1 is negative 4. Then minus another one is negative 5 over 2k is equal to negative 3 times 2 is negative 6, minus 1 is negative 7 over 2. All right. And then here, we want k to be by itself. So the way I'm going to make negative 5 over 2 equal to 1 is, again, I use the opposite operation. So because it's negative 5 over 2 times k, I'm going to divide both sides of my equation by negative 5 over 2. Okay, and that's going to cancel that out. I'm left with k. And then this gives me negative 7 over 2. And since it's divided by negative 5 over 2, I'm going to multiply by the reciprocal. So times 2 over negative 5. And that's going to give me a final answer. K is equal to, the 2's here cancel out. I get 7 over 5. Or to put in a proper fraction, 1 and 2/5. Okay? So that would be, both of those would be acceptable in this case. Okay, probably the mixed fraction would be the best answer. Okay, so there's some fraction work there that you'll have to remember from earlier on this year and from previous years in math. Okay, so here, again, turned, it was negative 2 times 2, which is negative 4. And then minus 1, because it's a negative instead of plus 1. Same thing here. Okay, negative 3 times 2 is negative 6. And then minus 1 was negative 7. Okay, and then it's, negative 3 over 2 times k. So I'm going to divide both sides by negative 5 over 2. That's going to cancel out the negative 5 over 2 because it's the opposite operation. And you know that negative 5 over 2 divided by negative 5 over 2 is equal to 1. And 1 times k is equal to k. Okay, that's kind of how you get there. 1 times k is equal to k. Those are kind of the steps that you think about. Okay, that's why we use the opposite operation. And then from there, instead of dividing a fraction, we multiply by the reciprocal, then we simplify our solution. Okay, go ahead and pause the video and take your turn at solving these 3 questions here. All right, hopefully that went well for you. Let's go over these together. All right, opposite operation. I'm going to divide both sides by 3. That's going to cancel out my 3's. I end up with x is equal to negative 2 over 3 divided by 3, right? Or divided by 3 over 1. Which is going to equal to, I'm going to move here, x is equal to negative 2 over 3 times the reciprocal, 1 over 3, right? Make that in red so you can see where the changes are coming from. Then I do tops times top, bottom times bottom, and that's going to give me x is equal to negative 2 times 1 is negative 2, and then 3 times 3 is 9. That would be my final answer for x. Okay, and this one here, I have 2 methods I can use. I can use cross multiply or just opposite operation. All right. I'm going to stick with opposite operation here. I guess we can do both methods. So we'll do opposite operation first. So x divided by 2 is equal to 5 over 6. Because it's divided by 2. Because here it was 3 times x, I divided 3 on both sides. Here, because it's x divided by 2, I'm going to multiply on both sides, because multiplication is considered to be the opposite of division. Okay, 2's cancel out. And then I end up with x is equal to, and of course this is 5 over 6 times 2 over 1, right? So 2 times 5 is 10, 6 times 1 is 6, and that would reduce to 5 over 4, or even further reduce to 1 1/4 for improper fractions. Okay, for cross multiply, I'm going to get the same answer here, but a different method. So x, I'm going to rewrite my problem, x over 2 is equal to 5 over 6. Cross multiply again, 5 times 2 is going to be equal to 6 times x. So let me write that out. 2 times 5 is equal to 6 times x. So 10 is equal to 6x. And then I want to isolate the x. Even though the x is on the right side of my equation, it doesn't matter what side the x is on. Okay, you want to isolate it where it is. So it doesn't always have to be on the left side of the equation. I can isolate it on the right side of the equation. And so I do this by the opposite operation, 6 times x. So I divide both sides by 6, right? And that's going to cancel out my 6's because 6 divided by 6 is equal to 1, and 1 times x is equal to x. And then 10 is equal to 10 over 6, which I already saw reduces to 1 1/4. Same thing. Last example. Rewatch it if I'm going too fast, okay? Here, I want to turn everything to improper fractions. So here, negative 1 times 4 is negative 4. Minus 1 is negative 5 over 4. Y is equal to 1 times 4 is 4, plus 3 is 7 over 4. All right, so here, because it's negative 5 over 4 times y, I'm going to divide both sides by negative 5 over 4. Okay, that's going to cancel those out. I'm going to end up with y is equal to 7 over 4 divided by negative 5 over 4, which I'm going to multiply by the reciprocal. Y is equal to 7 over 4 times 4 over negative 5. And that's going to give me negative 7 over 5. Put the negative kind of in the front. Negative 7 over 5. And I can make that a mixed fraction here of negative 1 and 2 over 5. All right, again, go back and review your fractions, mixed fractions, two whole improper fractions in the past here. All right, those are topics that we've covered. Let's solve a few more problems here. Example 2, solve equations with decimals. So nothing should change here in our approach of solving equations. All of the rules we mentioned above should still be applicable to the following equations. So it doesn't matter if it's decimals. You just probably have to plug it into a calculator now. So because it's negative 1.2 times x, I'm going to divide both sides by negative 1.2. Okay, negative 1.2 divided by negative 1.2 is equal to 1, so they cancel out and it leaves me with x. And then negative 3.96 divided by negative 1.2 gives me my answer on the other side. It gives me positive 3.3. Okay, and I can double check my answer. I can take 3.3 and plug it in to the place of x. So negative 1.2, x is equal to negative 3.96. I can plug what I think to be my answer, 3.3, into x, and it should give me a true equation. So times, so if I do negative 1.2 times negative 1.2 times 3.3, I get negative 3.96 is equal to negative 3.96. Okay, and my equation is still true, so I know that this is the correct answer. All right, let's do another example here. All right, here I have r is equal to 0.28. R over 0.28 is equal to negative 4.5. Okay, so again here, I'm doing opposite operation. So because it's r divided by 0.28, how I'm going to turn that into a 1 is I'm going to multiply 0.28 on both sides. Okay, 0.28 divided by 0.28 is equal to 1, so they cancel each other out. So I get r by itself. And then on the other side, I get negative 4.5 times 0.28. And I get my solution of negative 1.26. It's as easy as that. Oops. All right, good. Hopefully that worked well for you. Go ahead and pause the video. Well, go ahead and try some of these on your own in the your turn section. Try these 2 questions. Pause the video and then unpause it when you're ready to go on together. All right, hopefully that went well for you. Let's try solving these here quickly together. So here I have u over 1.3 is equal to 0.8. Okay, and then it's u divided by 1.3. So I'm going to do the opposite operation. I'm going to multiply 1.3 on both sides. So that's going to, the 1.3 divided by 1.3 going to cancel out. Leaves me with u. And 0.8 times 1.3 gives me 1.04. And that is my answer. Okay, again, you're trying to get the u part of it by itself. All right, let's try this next one here. It's 5.5 times k, so I'm going to do the opposite operation and change that 5.5 to a 1 by dividing both sides by 5.5. Whatever I do to one side, I have to do the other side. 5.5 divided by 5.5 is 1, so those just cancel out. I'm left with k. And then I just plug the right side of the equation to my calculator. Negative 3.41 divided by 5.5. And I get negative 0.62. And that is my answer. Hopefully that went well for you. Keep practicing. Okay. Sometimes you'll see questions that are a little bit different here that might be a little bit trickier. I'm solving equations in the form of a over x equals b. Okay. So solve the equation 88 over x is equal to 11 and check below. So what do you do when there's a variable in the denominator? Which opposite operation should you use? Okay, so here, essentially you have to kind of bring your variable back to the numerator position and then isolate the variable. Okay, so in this situation, I have 88 over x is equal to 11. Okay, what I'm going to do is I have to get that x out of the denominator. Okay, so how I'm going to do that is I'm going to multiply both sides by x. Okay, I'm going to leave the 88 where it is, and I'm going to multiply both sides by x. Okay, 88 times x divided by x, or x times x, is just equal to 1, so they cancel out. I'm left with 88 is equal to 11 times x, 11x. Okay, and now hopefully you see this and you breathe a sigh of relief, like, oh, okay, I know how to do this. Okay, because now you're just isolating x, and it doesn't matter that it's on the right side. The variable can be on the left or on the right, doesn't matter. Okay, just as long as you isolate it. So here it's 11 times x, so I'm going to divide both sides by 11. 11 divided by 11 is equal to 1, so I get x is equal to, and 88 divided by 11 is equal to 8. And that is my answer there. Okay, again, you can substitute to make sure. 88 divided by 8 is equal to 11. 88 divided by 8, yes, that's equal to 11. So your equation is for sure correct. So you know that this is the right answer. Okay? So beware of those problems, okay? That you kind of have to turn those into a two-step problem. All right? Multiply both sides by the variable. If the variable, and you only use this approach if the variable is a denominator. If it's in the numerator position, you don't have to do this, right? You can just work as we've done in previous questions, right? But if it's in the denominator position, you have to bring it up to the numerator first, and then isolate it. So it gives you an extra step to do. All right, so now that we've figured this out, let's take a look at the following word problem. The formula for speed of an object is speed is equal to distance over time. S is equal to d over t, where S is speed, d is distance, t is time. The length of a Canadian football field, including the end zone, is 137.2 meters. If a horse gallops at 13.4 meters per second, how much time would it take for the horse to gallop the length of the field? Express your answer to the nearest tenth of a second. So here I have a bunch of variables given to me. I have an equation, S is equal to d over t. And I'm going to take an inventory of the variables they give me in the question. Do I have S? Do I have speed? Yes, I have speed. If the gallops at meters per second. That's like kilometers per hour. That's how we measure speed in a car. Meters per second is similar. All right, so speed is 13.4. Okay, do I have distance, total distance? Yes, I have the length of the football field, which is 137.2. Okay, meters, this is meters per second. Do I have time? No, this is what they're asking for. How much time? How much time? In seconds, right? So this is what I'm solving for. Okay, so I'm going to substitute the values that I know into my equation. So S, instead of writing S, I'm going to write the value of S. 13.4 is equal to D. I have the value of D, 137.2 over T. I don't know what T is. That's what I need to solve for. Okay. Now my variable is in the denominator, so I know the first step I need to do is to multiply both sides by T in order to get that variable out of the denominator. So here I get I get 13.4 T is equal to 137.2. Now in order to get T by itself, because it's 13.4 times T, I'm going to divide both sides by 13.4. Yeah, and because, same reason here, because 13.4 divided by 13.4 is equal to 1, they cancel out. I end up with T by itself. Okay, and then I do 137.2 divided by 13.4, and I get my final answer of 10. And where should I round it? The nearest tenth, 10.2 seconds would be my final answer. It'll take a horse 10.2 seconds to run the length of a Canadian football field. Okay? So that's how you do a question like that. Write down your equation, identify your variables from the question, figure out what you're solving for, what you have, and then go to work with your algebra. Okay? Try one on your own. Go ahead and give this one a shot. Pause the video, answer it, and we'll come back and do it together. All right, hopefully that went well for you. Let's give this a shot together. Winter Warehouse has winter jackets on sale at 25% off the regular price. If a jacket is on sale for $176.25, $176.25. That was harder than it needed to be. What is the regular price of the jacket? Aha. Okay, so this is there's some components here to this question that are a little bit tricky, but hopefully you were able to determine this. And so here, if I were to come up for an equation for this, something like this, I would do kind of the original price of jacket and then here it would be maybe times the discounted rate is equal to the sales price of the jacket. Okay, so now we got to figure out, okay, what are the original, do I have the original price of the jacket? No, right? That's what the question is asking me. What is the original price of the jacket? All right, next, do I have the discounted rate? Now here, we do have it, but it's not as obvious as it looks. Here, if the price of the jacket was discounted by 25%, how much percentage of the jacket of its original price did the person pay? And the answer is they would have paid 75%, not 25%, okay? Because if you reduce the price by 25%, you're left with 75% of the price that you have to pay, okay? Now, it's better than paying 100% of the price, but you're not paying 25% of the price. You're reducing it by 25%, leaving you 75%, okay? So if I have the original price of the jacket, which I'm going to use this symbol for, it's probably not a good symbol to use, but I'll use it for this question, times 75. And now when you're dealing with percentage, 75%, you have to use decimals in math equations. So this changes to 0.75. So that's my discounted rate. Okay, and then that's equal to my sales price. My sales price is what I paid, which in this case is 176.25. So that would be my equation. The original price of the jacket times the discounted rate, or 0.75, so 100% minus 25% leaves you with 75% of the jacket to pay, is equal to $176.25. So now my variable is this here, right? And I need to isolate my variable, and it's because it's original price times the discounted rate. I'm going to divide both sides of my equation by 0.75. Okay, that's going to cancel this out over here, leaving me with just the original price of the jacket. And then I just plug my solutions, I just plug it into my calculator. 176.25 divided by 0.75. And I get the original price of the jacket, which was $235 for the original jacket. Okay? So that's how you solve a question like that. That was a little bit tricky. Percentages, watch out for percentages, change them into decimal form, and try to come up with an equation. Okay? You'll have some practice problems here. We're starting with the get ready of the chapter. We're not jumping into section 6.1. That'll be at the end of the next notes. But for this homework, you're doing the get ready section in the textbook, numbers 1 to 7. Okay? So hopefully by now, you can model problems with linear equations involving one operation, and that you can use multiple strategies to solve these operations. Hopefully this video was helpful to you. Reach out to me if you have any further questions, and we'll see you next time. Goodbye.